All right, hello there, computer science folks. This is a Restall's short little spiel on the switch structure. In your reading, and on Edmodo or no, it's attached to the website maybe. Anyway, there is this little tiny program where you enter what should be a mark out of 100, and it reads it in, and then you know, does integer division. So mark div 10 is an integer we see, and then uses an if structure to assign a letter grade, right? So a few little comments about this. Um, this if else nested if else, it looks pretty confusing, but it's not so bad to read um, if the indenting's right. But if the indenting weren't right, say this was back here, it can be very difficult to follow what the heck's going on. So um, sort of more simpler is the switch structure that you've been reading about and that we'll talk about shortly. A few things that I want to point out. First of all, remember that these two vertical lines here is um, the the we think of them as or. So this condition is true if this or this is true. Okay, and that kind of makes sense because if you take your mark and divide by 10 and it's an 8 or 9 or 10, then you've got an A, right? That makes sense. Um, a couple other things. So that's or, and notice it doesn't say mark div equals 8 equals 9 equals 10. We have to have the entire comparison. This or this or this. That's an entire comparison. And notice that the two equal signs is for a comparison where the single equal sign is for an assignment. Okay, remember that. Two equal signs, comparison, one equal sign, assignment. Dandy. The other thing I wanted to remind you of there, and it's in green comments, is that chars, characters, are in single quotes. Okay, are in single quotes. If I were to use double quotes like these, that is a string all of a sudden. And remember, strings are kind of nasty to compare. And as we'll remind you of soon, um, in the switch structure, it doesn't work with strings. It works only with primitive data types like ints and chars, and that's it. Okay, what else did I want to mention? I also want to mention that notice that whenever we did if structures, we had the start and end quotes, okay, like this. Or sorry, start and end brackets. And some people use the start and end brackets up here, and that's fine. Um, I wanted to mention that when it's only one statement, like in this case, when it's only one statement, then the curly brackets are not necessary. If I were to have another statement like C, if I had in here C dot print line hello, then only this one would be run, and then in fact this would kind of be back at this stage, and I'd probably get an error message because there's no if that goes with this else. This is one command that ends here, and this is kind of in the way. So when there's one statement, we can get lazy and leave out our curly brackets, but when there's more than one statement, we need to put those curly brackets in. And we see this nested if, and actually it talks about one of the advantages of the switch command, which we're going to see in a second, is the default. But we can always have a default in an if structure. It's possible, right? There's the default. If none of these things work, then this would be the default grade with a little message. And notice that I did use my curly brackets there because there were two statements in that code chunk. All right, dandy. The switch statement. Here's another thing. I don't know if you saw this yet, but you can comment out whole blocks of code um, just by using that edit. So I've got the switch statement in here, and I'm going to uncomment that so we can see it now. So the switch blah, and this isn't a comparison now. This is what we're asking the computer to do is to take all the different cases of whatever mark div 10 could be, and remember It only works for integers and characters. Doesn't work for strings, doesn't work for doubles, integers and characters. And then we use the keyword case, and then there's some code. And notice that the switch statement itself doesn't have a semicolon, but it does have a curly brackets. And then if it finds that one of these, the mark div 10 is one of these values, it's going to run this code. Now, another important keyword here. Notice no curly brackets there. Curly brackets on the entire structure, but not on the cases themselves. Don't have curly brackets. There's a keyword here, break, and this is an important thing. This is if the program finds one of these, it'll start executing codes, statements with this line. And if this break weren't here, it would actually reassign these other and execute these commands as well. So this break command is like a get out of jail free. Well, not free, but get out of jail. So after it assigns this grade, then it reads break and then it clunks out. Okay, so it doesn't execute these. And if you were to leave out a break in your switch statement, then you're going to get an error. You're going to get a logic error, because even though the syntax is correct, it would, let me show you that. So if I leave out that break and run this, type in a markout, say if I put in 87. 87 is a letter grade of B, which is incorrect. Well, what happened was it found this case, it ran this line and assigned A to grade, but then didn't find a break statement, so it executed this command as well. So you have to put the break command in there. And of course, one of the nice advantages of switch, besides they're way easier to read, is that it has this default thing, right? So if I were to run this and put in something like 788, there's a default. Now, of course, we could have had the default up here as well. And notice that one of the things down here, if grade is not equal, this is sort of make sure that you have a grade to enter. If grade wasn't assigned and this statement were to run, it would give me a runtime error message because grade was undefined. And that was one of the things we ran into with our if structure in the note before we had that default a grade assignment of question mark. All right, I think there's an assignment, a little tiny program to write to practice the switch structure, and then you're on to your programming assignment number 1.